this. YouTube. Patterning, okay. Your channel. Okay, live this one. And copy. This one. We try. This mouse. I gotta reuse the sure. Very sure.
โอเคครับI hope that you can hear me right ในนี้มันกระดิกแล้วนะครับผมก็ไปไม่เป็นไรใช้ไมค์อันนี้ก็ได้อ่า everything is alright ทุกคนได้ไหมครับคือจะใช้อีกเครื่องนึงเปิดอันนี้ไปคือมันเปิดได้ครับแต่ว่าผมแชร์ไม่ได้แอคเคาท์คนที่น่าจะเป็นคนที่ใส่หมวกอะตัวผมเองอะครับอ่าคือใช้คอมพิวเตอร์อันนั้นนะครับแต่ว่าจะดันหน้าจอไปแชร์ที่ในซูมอะครับผมเหมือนว่าผมทำไม่ได้มั้งคุณจะได้เห็นชัดๆนะครับซูม US KV เซนอ๋อแชทเห็นปัญญาละบิลเชิมเนี่ยเขาก็ไม่ให้แชร์อีกนะครับเนี่ยเขาบอกว่าโฮสต์ไม่ให้ไม่ให้แชร์หน้าจอแล้วผมจะไปปลดล็อกไงก็ไม่ทราบครับอืมโอเคโอเคครับไม่รู้ว่าโอ้เละแล้วนะครับแต่ที่ YouTube นี่ยังได้เนาะนะครับนะเปิดจอนี่ IRB this problem right แต่มันก็ไม่ชัดเนาะอันนี้ lecture note right this one อืมนะครับที่ YouTube ผมเปลี่ยนมาที่หน้านี้แล้วนะครับส่วนตัวซูมใช่ไหมครับผมต้องไปที่ Good Note ใช่ไหมครับแต่ว่ามันก็เอาหน้าจอออกไม่ได้ได้หรือเปล่าโอเค not sure here we we have a problem and we need to find the current that flows through a long straight wire. Okay, how much we should let the current flows in that the copper wire. ผมไม่ค่อยถนัดครับเอาหูฟังเสียบหูนะครับขออนุญาตถอดนะครับถ้าคุณมีอะไรคุณพิมพ์มาบอกมาได้ไหมครับมันมันสะท้อนที่ผมพูดนะครับ Okay, we arrived at this example, right? In we have to find the currents. So let's go back to the to the Biot-Savart formula, right? Here we have B equals mu 0 I divided by 2 pi r ผมลืมบอกเรื่องข้อสอบจนหมดครับอีกข้อที่3นะครับจะเป็นเรื่องเขาเรียกว่าอะไรเอา polarization filter 2 อันมาบวกมาวางซ้อนกันนะครับใช่ไหมแล้วก็เรื่องที่4เป็นเรื่องของ reflection ที่มีน้ำตกกระทบกับสระว่ายน้ำนะครับแล้วก็นั่นคือกลางวันใช่ไหมครับแล้วก็ floodlights นะครับก็คือ spotlight ที่อยู่ใต้สระน้ำแสงพุ่งขึ้นไปนะครับผ่านอากาศนะครับแล้วก็นั่นแหละครับข้อแรก1 คะแนนนะครับเรื่องความยาวคลื่นเนาะแล้วก็ข้อที่2 AM amplitude modulation ก็1 คะแนนนะครับข้อที่2เรื่องฟิลเตอร์ใช่ไหม polarization filter 2 คะแนนนะครับแล้วก็ข้อสุดท้ายนะคุณจะเห็นว่า1 1 2นะครับแล้วก็ข้อสุดท้ายข้อ4ประกอบไปด้วย4 คะแนนนะครับเพราะว่ากลางวันถาม2 คำถามแล้วก็กลางคืนถาม2 คำถามก็ข้อสุดท้ายก็รวมเป็น4 คะแนนดังนั้น1 1 2 4นะครับก็จะรวมเป็น8 คะแนนแล้วก็บทที่2ก็จะเป็น12 คะแนนนะเพราะว่าปัญหายากกว่าแล้วก็เยอะกว่านะครับก็ครั้งหน้าคุณจะเอาสอบแบบเต็มคาบใช่ไหมครับวันอะไรนะวันศุกร์ใช่ไหมครับวันศุกร์ตอนเช้าคุณเอา 8:30 until 10:10 นะใช่ไหมครับได้ยินเสียงผมไหมครับเดี๋ยวผมขอมอนิเตอร์เพื่อคุณอาจจะพิมพ์มาที่ YouTube นะครับทำไมไม่ไปชื่อ this โอเคขอเช็คนิดนึงครับที่ไม่มีใครพิมพ์มานะก็ชัดอยู่นะครับที่ YouTube นะครับไม่รู้ว่าเสียงเป็นยังไงบ้างโอเควีนะครับเรื่องข้อสอบก็แจ้งคุณไปแล้วนะครับว่า8 คะแนนครับคุณเอาเต็ม1 ชั่วโมง 5เท่าไหร่นะ8:30 10 มันประมาณชั่วโมงกว่าๆครับคุณเอาเต็มค่าใช่ไหมครับไม่เอาแบบ1 ชั่วโมงสอบเสร็จแล้วเรียนต่อใช่ไหมครับมีคนไหนบอกเสียงผมแล้วได้ไหมครับเพราะว่าผมจะได้แจ้ง605เช่นเดียวกันนะครับถ้าคุณได้ยินที่ YouTube นะครับช่วยพิมพ์ตอบนิดนึงนะครับว่าคุณจะเอาเต็มใช่ไหมเต็มเวลานะครับไม่ได้แบบว่าสอบเสร็จแล้วก็เรียนต่อนะ so we have to apply let's get back to the example here in the slide we would like to find the current right so from this equation we have to arrange move everything okay except for the variable I okay to be at the left hand side. Okay, move 2 pi r to the left hand side, so 2 pi r is going to stay at the numerator position, right? In 10 right? It's it's 12 40, so 14 20, right? Okay, 2 pi r will stay at the numerator position, okay, in the upper part on the right, on the left hand side, right, of this equation, in equation number 25. And mu 0, which is the only constant, okay, on the right hand side at the numerator position, will appear here, okay, on the left hand side as the denominator, and that's the expression we would get easily, okay, from like this, okay. Mu 0 will be only the constant that appears in the denominator position, okay. Apart from that, 2 pi r and b and so on will stay there, okay. But from what they want here, they said a magnetic field twice the strength of the earth, so the variable b, okay, should be the one that has the variable b should be the one that has that should be equal to 2 times the magnetic field on earth, right? So we will substitute b by 2b earth, okay, and we will let b earth be any value according to what the problem gave, okay. If the problem doesn't give us the value of the earth magnetic fields or magnetic flux density, we're going to use the previous value of the earth magnetic field, okay, which is of I think 50 micro Tesla, right? And if you represent it into the normal SI normal or SI scale, right? Without micro prefix, okay, without micro prefix unit, it's going to be 5 times 10 times 10 raised to the negative 5 in okay, number 2 will stay here on the numerator, okay. In of course the value for r, right, what they have provided is at a distance of 5 centimeter. All right, 5 centimeters, okay, is the value for r, right? But it's not appropriate for us when we want to get the final answer in the SI scale, okay, which is ampere, okay. We have to convert the 5 centimeter into the typical value in the SI scale, okay, which is meter, and 5 centimeter is equal to 5, okay. We use the same number, but we have to multiply it, okay. We convert the centi to the one without centi prefix, okay. So it means the multiplication with 10 raised to the power of negative 2 here, okay. In 2 pi is the normal thing, right? In of course we put, okay, when we observe that everything is represented in the SI scale, okay, meter, okay, not millimeter, not centimeter, not kilometer. This one is simply Tesla, okay, without micro Tesla or milli Tesla. In the mu 0 is the constant, right, from the Biot-Savart law, right? It's 4 pi times 10 raised to negative 7. I think in the exam, or in the problem in the midterm exam, they would not there would be no value of mu 0 provided to you, so you need to be able to remember the value of mu 0 yourself, okay. 4 pi, it's not difficult. 4 pi times 10 raised to the negative 7, okay, and the unit for mu 0 is Tesla meter per ampere, okay. Please note that the value or and the unit of mu0 will play a significant role in the following, okay, in the topic of two conductor wires as well, okay, or the yes, two conductor wires, two parallel conductor wires, okay, that will bring the magnetic force again. Okay, the Biot-Savart law will serve as the basic in the next few topics, okay, and you put everything, okay, after you are sure that every terms are represent in the normal SI scale, okay, normal SI units. So you put it into the calculator, you get 25 ampere, okay, it's not difficult. Now we finished the story about Biot-Savart law. Okay, simply speaking, it's Biot-Savart law, or the full name of this topic is magnetic field that is induced by the conductor that has current flow. Okay, and we move to another topic, which is this one, okay, magnetic force on current carrying conductor in yeah, it's the extension from the previous topic, okay, the story before Biot-Savart law, which is F equal absolute QVB, right? QVB sine theta, right? And that's the force, right, induced on a charge, right? And when the charge is moving in the area that has magnetic flux density or magnetic field, right? In this topic, the magnetic force on current carrying conductor is another topic that's use the basic idea from that one. Okay, let's consider this environment. Okay, if you still can remember what is the meaning of the cross signs here in this area. Okay, the X signs or the X symbol represent the tail of the arrow, right? And if we have the dot, it means we are seeing the head of the arrow, okay, and that arrow is the vector of magnetic field, right, or magnetic flux density. That's the B vector, okay. In our terminology, we call this is the B vector, right? And in this case, the magnetic field vector is pointing into the plane of direction node, okay. It's pointing into the plane of this one, okay. That's why we see only the tail of the arrow of the vector here. Okay, right now we have several vectors which is magnetic field lines, okay, magnetic field lines in this area, okay. They just draw simply as the rectangular shape, okay, but actually there could be more magnetic field lines, okay. And let's say we have a cylinder shape here which represents a part, okay, a part of the long straight copper wire, okay. Actually the copper wire is a cylinder, has the cylinder shape, right? It's just straight and it's long enough, okay. And we are considering only a section which lies in the area of the magnetic field, okay. And of course, let's go into the detail or the mechanism that happens inside the copper wire, okay. Yeah, as you know, if you study the chemistry before, the particle that moves in atom, okay, in metal atom is electron, right? It's not a proton, it's not positive charge, okay? But here is the pseudo, okay? The virtual, the non-realistic, but it's easier to understand, okay? They just say that it is equivalent to the case when the positive charge is moving, okay? Let's say here the positive charge moves, okay, from the bottom of the conductor part or the copper wire part to the upper part, okay, of the conductor in but actually it's not the case, right? The particle that moves is electron, right? It means electron moves downwards, okay, move downwards here, but in the typical notation from an American analysis, a person there in the United States, they use the convention of positive charge, okay, but actually positive charge like proton in nucleus of any atom doesn't move, okay, but it's the pseudo version, okay, it's the artificial version which is easily understandable to us, okay. Positive charge moves in this way, right? Let's say the positive charge moves in this way, and you don't need to take care about the connector, the metal which is made of copper at all, okay? You can use the knowledge from the previous topic that if you see the positive charge moving like this, okay, upward like this, and the magnetic field is pointing into the plane of this lecture notes, okay, of this paper, of course we can use or apply the right hand rule, right? You just start you can use the formula vector f equal the scalar q, okay? Q is the amount of the charge, okay. This one is positive charge, so it's positive already. So vector f is equal to scalar q and open parentheses, right? Vector v, okay, the direction vector or the movement vector of that particle, of that charge, okay, which is upright here, okay, in cross, right? I have shown you the cross version of this one, right? The cross or the cross product, right? It's just the same here, okay. The multiplication sign cross the second vector, okay. The second vector is the b vector, right? The b vector is the magnetic field vector, okay. You just like your four fingers, your right hand, okay, your four fingers upward like this, and of course the second vector is the magnetic field vector which is pointing into this plane, okay. You curl or your roll or you rotate your fingers which is upright to the direction of the magnetic field inside this plane, inside this paper, and after that you can observe your ถ้าใครอยู่ที่ YouTube นะครับก็เดี๋ยวผมทำมือมันจะมีกล้องหนึ่งเล็กๆนะตรงนี้นะครับตรงนี้นะครับthis is the direction of the vector v, right? And we curl or we rotate our four fingers to the direction of the second vector which is magnetic field, okay. And what you find is that your thumb direction นะครับทิศทางของนิ้วโป้งนะครับ will represent the outcome vector which is the vector f here on the whiteboard on the lecture notes, okay. Curl rotate your four fingers from the green vector to the vector which is pointing into this plane, into this paper, okay. And your thumb direction, okay, the single finger that will give you the outcome or the output vector, which is vector f, right? And that's the previous knowledge we get in previous topic, right? Okay, here they have the vector, the arrow which represent the current direction, right? It's in the same way as the velocity vector of the positive charge. Okay, and let's go into more detail into the structure of this copper wire. It's a section of the cylinder copper wire, right? So if we make the cross sectional, okay, we cut the copper wire. Of course, even the copper wire is tiny, but it still has the cross sectional area. Let's say the cross sectional area is denoted by the variable a, okay, and the part, okay, the portion of the conductor is of the length L, okay, we cut it and we consider actually the copper wire is long, is straight, okay, very long, but we will consider only a part of that, and that part will last only L meter, okay, let's say is the variable L is the part of the conductor that we are considering. Okay, let's move to the next page. This one is taken from another book. Okay, I'm not sure whether you can see it in Zoom. ที่ Zoom นะครับไม่รู้ว่าเขาเอาจอไหนนะ iPad มันควบคุมไม่ได้นะครับมันสั่งไปก็ไม่ได้ใช่ไหม this one, right? Figure 33 is the same as the previous figure. Okay, this one is taken from another book. This is a part of the conductor, right? We have to finish at 14:10, right? Otherwise M605 is going to complain me. What is going on there? Okay. Okay, this is the part of conductor that they are considering, right? It's denoted by, again, the variable L, okay, but it's written in a different font, okay, it's only L, okay, and of course there is magnetic field which is pointing into, again, the into the plane of this lecture note. Okay, and consider the you may consider the conductor as the pipe, okay, the pipe that allows water to flow, right? So it has a cross-sectional area which is circle, right? And here A, okay, you can make the conductor to be in a cubic shape, okay, which has square cross-sectional, but it's not typical. Usually the copper wire is made like a cylindrical shape, okay. It's very that you have the conductor as the square as the cross-sectional area, okay. And when we let the current go into this conductor, it means it means artificially, okay, it's not true. It's in the pseudo idea that the positive charge is moving, okay, but actually it's not moving. Proton cannot move because it's the nucleus, the heart of any atom, right? The positive charge moves, okay, in this direction from left to right, and of course you can apply again your right hand, okay. This is the vector F is scalar q, right? And open parenthesis, the first vector, which is the vector of motion of the charge, okay, vector v, okay, the first vector cross, right? Cross means rotate your four fingers to the second vector, which is vector b, okay, which is pointing into this plane. And of course, when you use your right hand, right, this direction, and you curve it and you get the direction which is the outcome, okay, that's the vector F, Okay, the vector f is the output or the outcome of this process, okay, of the vector cross product. And yeah, it's the formula you have seen, right? FQBB psi theta, right? In that's the force which happens to only a single particle or single charge, right? But when the clean fluids, there are a large number of particles of positive charge movement. So we will talk about that in figure 32. The magnitude of the magnetic force F, right, is computed by F absolute Q VB sine theta, right? And in whether 32 or 33, the angle between V and B, right? This is pointing upward, and vector B is pointing into the plane. So the angle between those two vectors is gonna be 90 degrees, right? So sine of 90 degrees is 1. So this term, we don't need to represent this term at all because it's only number 1, right? It's meaningless. We just leave it, okay? But it's not 0, okay? If this term is 0, everything will disappear, okay, on the right hand side of this equation. So psi is number 1. So here psi will disappear. And we have, what we have is only absolute Q VDB, right? VD is the drift velocity, okay? You may ask me what is the meaning of the subscript D ผมไม่ได้แต่งเองนะครับ D เอามาจากหนังสือแล้วเขาห้อย D ผมก็ห้อย D นะครับโอเคไหมwhat is the meaning of the subscript D? D stand for drift, okay? DRIFT, drift velocity, okay? Because the current, the copper wire doesn't move, okay? The particle that moves, or the object that moves, is only the charge, right? So that's why they say drift velocity, okay? It's the velocity of the particle inside the conductor. The conductor doesn't move at all, okay? The conductor stay at the same position, okay? You would have never seen the conductor that moves, okay? Otherwise the conductor on the road will move all the time, okay? The conductor or the copper wire just stay idle, okay, on the road, okay? But the particle inside the conductor are moving, okay? And that's why they say drift velocity. In of course, B is the magnitude of magnetic field, F is the magnitude of the magnetic force. That's what we have seen before, right? Theta is 90 is the angle between vector VD and vector B. In that's what we have seen from single particle positive charge, right? But assume that at a certain time there is not only single particle or single charge that moves, okay? There are n number of particles that move, okay? Let's say we have n positive charges in that area, okay, at a certain time. Okay, let n be the index of the particle, okay? Assume that every particle moves with the same velocity, with the same speed, okay? And the magnetic field is uniform, right? And for the n moving charged particle, we apply the FQVB sine theta to each particle, and for the n particle we get the same amount, right? This, right? Qn, which is the amount of charge in that particle, and Vd, let's say every particle, every charge moves with the same speed, okay, with the same magnitude of velocity. And B is uniform, okay, it's constant for every charge, okay, for every movement at that time. And when we take a look at our particle movement, there will be speed, right? Speed is the basic quantity you can observe in physics, right? In Mathematics 4 or in Mathematics 5, right? speed is the distance divided by time, right? Let's say the chart start from one end in the one end in the portion of the connector that we consider. Okay, let's say the chart start from this one. Okay, at the if you look at the Olympic 100-meter running, they start from the starting point, right? And when the referee take beat, okay, the voice, okay, the starting voice of they just move right with the constant velocity, with constant speed, and here is the ending point, okay, the portion that we consider the movement of this chart. Okay, you can see that the distance that they move, okay, all the charts move is L, right, is of the length L, and let's say the movement in this portion last delta t, okay, delta t second หมดเวลายังครับอีก2 นาทีนะ Okay, we get the velocity Vd, okay, the magnitude Vd of each particle, and let's say every chart has the same velocity Vd L divided by delta t. And do you know that if you, this is the highlight of this topic, okay, if you don't let any current flow into this conductor, I think I have to quit this lecture, right? Because Dr. Shoksan had mentioned that I have to let you quit earlier so that you have enough time to prepare for the next subject. I'm sorry for that. ขออภัยนะครับวันนี้ใช้ iPad ครับมันติดขัดนะครับควบคุมหน้าจออะไรไม่ได้ครับเดี๋ยวผมก็ลองใช้แล้วนะครับเมื่อคืนนี้นะครับไม่ได้หลับไม่ได้นอนครับมันก็ยังเกิดปัญหาจนได้นะเมื่อคืนลองไม่มีปัญหาครับก็วันนี้ก็จบไปเพียงเท่านี้ครับกำลังขึ้นเรื่อง FILB เลยนะครับเราจะเปลี่ยนจากสถานการณ์ QVB เป็น ILB นะครับเดี๋ยวจะเล่าให้ฟังว่าทำไมเป็น ILB ก็พบกันวันศุกร์นะครับ 8:30 เนาะ 604 สอบก่อนครับอย่าคุณสอบเสร็จแล้วคุณอย่าไปบอก 605 นะว่าข้อสอบเป็นอย่างไรนะครับเพื่อให้มันยุติธรรมครับ Okay, FILB is going to be said later, so we have to quit the lecture now. If you have any questions, just let me know, okay? If not, then we have to say bye bye and see you on Friday, right? Okay ครับสวัสดีครับบ๊ายบายครับ in stream โอ้ทำไงเป็นโอ้เป็น